My name is Eric Zelo. I'm the chair of the Department of History and Philosophy and the chair of the Connections Lecture Series Committee. I'll just say something about the series, and then I will hand off the mic to our introductory artist. Something like that. The Connections Lecture Series has 2 events per year. We have one in the fall, one in the spring. And the purpose of the series is to showcase the fact that knowledge doesn't stop conveniently at department doorways, and it doesn't stop conveniently at disciplinary boundaries. We have a tendency, I think, to think within our disciplines, to think that I do biology, ergo all I need to worry about is biology, or I do chemistry, all I need to worry about is that. And the reality is that a lot of the most interesting things that happen where different disciplines come together. And also, it happens when people are savvy at communicating with a larger audience and communicating how all of those interesting connections happen. And so that's really what this is a series about. And our speakers all in some way or another manage to bridge those divides. So with that, I will hand the mic over to Melanie DiLorenzo, who had the fantastic idea to bring our speaker today to campus. And so thank you to her for that, and here you go.
Thank you all so much for coming. I am very excited to see all of you and very, very excited to have Sam Kean with us today. I'm just going to give you a little background and let you get started. Sam Kean is the New York Times best-selling author of Caesar's Last Breath, The Dueling Neurosurgeons, The Disappearing Spoon, which is my favorite book and also what introduced me to Sam Kean, and The Violinist. His stories have appeared in the Best American Nature and Science Writing, The New Yorker, The Atlantic Monthly, The New York Times Magazine, and Slate. And his work has been featured on NPR's Radiolab, Science Friday, All Things Considered, and Fresh Air. And he was also on the Calling yesterday, which you can listen to. So please join me in welcoming Mr. Sam Kean.
Well, hello everyone. Thank you all for joining me this afternoon. Can you hear me in the back? Is it loud enough for everyone? Okay, great. So I had a bad go of things in about 3rd grade or so. I came down with strep throat something like a dozen times that year. And every time I did, I got to stay home from school, so it wasn't all bad as far as I was concerned. But I was feeling kind of sick, kind of achy. My mother would get a little fussy, and she would come in and she would try to take my temperature with one of those old-fashioned mercury thermometers, like you can see in the picture here. And I admit I was a little clumsy when I was a kid. I was also very prone to talking to myself. And so sometimes, my mother would come in, she would try to take my temperature, put the thermometer under my tongue, and the phone would ring, something would happen, she would get distracted, I'd be alone, I'd start chatting with an imaginary friend or whatever, singing, whatever it was I was doing at the time. And then not infrequently, this would happen. The thermometer would fall out of my mouth onto our hardwood floor, and it would shatter. And then the mercury would go spilling out of the end of it. But I admit I was always kind of secretly excited when that happened because I loved watching the mercury go scattering all over. It was like these little liquid ball bearings were everywhere. And my mother was actually very cool about the whole thing. She never panicked. She never made us evacuate the house like you'd probably have to nowadays. She would actually get down on her hands and knees with a toothpick, and she would start to brush the little spheres of mercury toward each other. And I'd be kind of watching over her shoulder as she was doing this. My favorite part was when she had 2 little spheres right next to each other. And she would give them one final nudge. Then they would jump together into this slightly larger sphere that was perfectly seamless. And I just thought it was the most amazing substance I had ever seen in my life. I mean, mercury's a metal. It's heavy. It's dense like a metal. But this was very shiny, very attractive, but it was also a liquid. You could flow. It could move around like that. And I managed to accidentally break enough thermometers over the years where we had quite a nice collection of mercury. We kept it on a little jar on a knick-knack shelf in our house. If we'd been good that day, my mom would get it down, whisk it around a little bit for us. I have a lot of really nice memories of this element, mercury. And so when we got introduced to the periodic table the very first time, first thing I tried to do was find mercury on the periodic table. I looked top to bottom, looked every row, tried to find it, and I just couldn't find it. I did not see mercury on there. And of course, mercury is on the periodic table, but the symbol for mercury turns out to be Hg. Now, neither of those letters are actually in the word mercury. And I thought, well, boy, that's kind of stupid. Why would that be the symbol if those letters aren't actually in the word? So then I looked into it a little more, maybe got some help doing some research or whatever, and discovered actually that, oh, the symbol actually comes from some Greek and Latin words. So they knew about this element very long time ago in classic Rome and classic Athens. And I thought, boy, that's really interesting. I didn't know they knew about this metal all the way back then. And not only did they know about this metal, but they associated it with different things in their culture. There was a god, for instance, they associated with this metal, with mercury. Also a planet that they associated with it. And the more I looked into it, the more I realized that, wow, Mercury does have this really rich, interesting history. Alchemists, for instance, were obsessed with mercury. They were always doing different smoky experiments with it and poisoning themselves, but they loved dealing with mercury. When they were colonizing the New World, they shipped whole galleons with mercury on it to help out with gold and silver mining. So it played a role in colonizing the New World. There were even some unusual connections to American history. I'm from the Midwest. I'm actually from South Dakota. So we always had a very long Lewis and Clark section in our local history class. But there was one story about Lewis and Clark and Mercury that they didn't teach us in school for reasons that will probably become apparent as I'm going on here. So this story gets started with this guy right here, Dr. Benjamin Rush, one of the founding fathers of the United States. He signed the Declaration of Independence, that whole thing. And he was most famous, besides the Declaration thing, most famous during his lifetime for staying behind during a yellow fever epidemic that ran through Philadelphia in the 1790s. So a lot of other doctors basically just abandoned their patients, fled the city, but he very bravely stayed behind and treated a lot of people who wouldn't have gotten treatment otherwise. Unfortunately, his pet treatment for pretty much any ailment was this mercury compound that he would feed them, often until their hair started falling out, their teeth would get loose and fall out, they'd start drooling from the side of their mouths. At the time, the idea in medicine was that you wanted to kind of fight fire with fire. So if you had a disease, you were feeling bad, you wanted to give them something that would provoke a reaction. And mercury sure did provoke a reaction. It's a poison, your body doesn't want it in you. So it's not how we think about medicine now, but it was one of the theories at the time. Anyway, Dr. Rush thought this treatment was fantastic. So he started mass producing them, producing patent pills. And he packed 600 of them with Lewis and Clark when they went wandering through the wilderness. Each was about 4 times the size of an aspirin, so very, very large pills. Called them Dr. Rush's bilious pills. And there's really no delicate way to put it, but these pills were extremely powerful laxatives. They called them thunderclappers. And the idea was that if Lewis and Clark, they're out in the wilderness, they ate something they shouldn't have, they drank some questionable water, not feeling good, they could take one of these pills and it would flush them out. Again, mercury is a poison. Your body does not want it inside you. It will move through you very, very quickly. And we know that Lewis and Clark used these pills. And in fact, we know that apparently they worked quite well because they've had a bit of a side benefit for historians and archaeologists today, in that they can actually still pinpoint a few places where they know Lewis and Clark must have stayed because the level of mercury contamination in the soil is just too high for it to have been natural. So from this one element then, from just mercury, I learned some unusual American history, but I also learned a little etymology about word origins. I learned about alchemy. I learned about mythology, poison forensics, all these different things from this one element. And that's really how I got interested in science for the first time, I think, was learning about these stories about things like the periodic table, the human body, how our atmosphere works. And in fact, I really did think when I was growing up in South Dakota that I wanted to be a scientist. I was very, very focused on science, took all the science classes I could, things like that. Till I got and then I eventually went to college at University of Minnesota, and again was a physics major there, taking all the science classes I could. Till I got about 3 years or so into my physics degree, I just realized that something had shifted. Things kind of swerved on me a little bit. And I just realized I wasn't enjoying being in the science lab in the way I thought I would. I just didn't enjoy it as much as other people did. One reason why was, again, when I was doing the labs and things like that, something like this might happen every once in a while. I might drop something, break something. Maybe the thermometer should have been a little bit of foreshadowing for me there, but it's a bit frustrating when you feel like you're a bit clumsy with the equipment. But even more than that, I just realized that temperamentally, I wasn't enjoying working in the labs as much as a lot of other students did. And really, for the first time since I was probably 10 years old or something, I started to think, well, maybe I don't want to be a scientist. Maybe I should do something else with myself. And that was a bit of a scary moment for me. I'd been so focused on science for so long that it was almost like I didn't know who I was anymore if I wasn't going to be a scientist. And I've since learned that's actually fairly common for college students. You get there, you start off in a track, you think you're going to like it, and maybe you don't like it as much as you thought you would. Maybe you want to change up a little bit. And I did decide I wanted to change things up. I did keep going with my physics major, but I also ran to the other end of campus and decided to get an English major at the same time. So I was kind of working on 2 tracks, the English and the science. And I did enjoy my English classes a lot. I liked reading poems and plays and papers, things like that. I liked writing the papers, doing that kind of work. But eventually I missed the science. And I decided I still wanted to be involved in science, even if I wasn't in the lab doing science, making science, producing data every day. I still wanted to be involved in science. And writing about science, telling stories about science, ended up being a good way to kind of marry those 2 interests. So eventually I started writing for some newspapers, some magazines, and then a few years after that, came out with my first book, which is called The Disappearing Spoon, which is actually about the periodic table, so kind of jumping off that Mercury story. So the premise of this book was to find kind of a funny or unusual or spooky story about every single element on the periodic table. And I did manage to cram all 118 now elements into there. Some of them just make a cameo, short appearance, but I did manage to tell a story or find something about every single one of them. And I really had 2 motivations when I was writing this book. One of them was that, I don't know what your experience was with the periodic table in chemistry class, if you've blocked it out or if you remember any of it. But one thing I was always kind of frustrated about in our chemistry classes was that there were just huge swaths of the periodic table that we never, ever got to talk about. There were so many elements that never, ever came up in class, even one time. And so I just wanted to know, what are the stories of all of those other elements? I wanted to give them a bit of a personality as well. And the other motivation I had for writing it was kind of related. It was that I knew there were elements out there that everyone thinks they know pretty well. But if you look into their backstory, their history a little bit, they do have kind of a rich, unusual story to them. And probably the best example of that, of an element that we think we all know well but has a hidden, unusual backstory, is the element aluminum. So, of course, we all know aluminum today. It's in pop cans and Little League baseball bats, aluminum foil. In some ways, it's kind of a throwaway element, one we don't think about a whole lot. But believe it or not, for a long time during the 1800s, aluminum was actually the most precious metal on Earth. It was worth far more than silver was, worth far more even than gold was. And the reason why is that even though aluminum is very common, it's the most common metal in the Earth's crust, even though it's very common, it was always tightly bonded to another element out in nature, usually to oxygen. So it's not like you can go out in nature and find a mother lode of pure aluminum. It's in mineral form. It's not in pure form. So when scientists, chemists especially, in the very early 1800s started to produce the first pure samples of aluminum, it was considered kind of a miraculous metal. I mean, it was very light, but very strong, very attractive. It basically had everything you would want in a metal. And because it was so hard to produce and so expensive to produce, it became something of a status symbol for kings and emperors to get their hands on samples of aluminum. So right here, you were looking at an aluminum centerpiece that was created for one of the emperors of France. That is aluminum on the top, and then that's gold beneath it, because aluminum was the more impressive metal. So obviously, you would want that on the top. There was also a French emperor who had a prized set of aluminum cutlery that he reserved for his most favored guests whenever he had a banquet. And the lesser nobility were actually reduced to eating with gold knives and forks. It was considered very embarrassing to be seen eating with the gold knives and forks when there was aluminum silverware available. And even the United States got into this game a little bit. Does anyone recognize what this is right here? It's a bit of an unusual angle for it, but it's the Washington Monument in Washington, D.C. Yep. So when they were putting up the Washington Monument in the 1880s, as you can see here, the US government decided they were going to put at the very tippity top of that a 6-inch pyramid of aluminum. And they did that for a couple of reasons. One, if you've ever seen a picture of the National Mall or maybe been down there, you know the Washington Monument is sitting there all by itself and there's nothing else around it. So they knew lightning was going to strike it at some point. They needed a metal up there to act as a lightning rod to get the electricity safely to the ground. But the reason they chose aluminum, out of all the other metals they could have chosen, was that the US government was kind of bragging a little bit. They were saying, you know, we are such an up-and-coming industrial power that we can afford to put aluminum on our public monuments. Isn't that impressive? And there were other countries around the world that were very, very impressed with this. For a while, because not long after that, the aluminum market basically crashed completely. What happened was a couple of chemists, two European chemists and one American chemist, figured out how to mass produce aluminum, so produce it on an industrial scale for the first time. And the American chemist actually became very famous, a young man named Charles Hall. He actually worked on this, producing aluminum, as his undergraduate thesis project when he was at Oberlin College in Ohio. And shortly after graduation, he had the breakthrough moment, figured out how to do it. So not much older than a lot of people in this room, he figured out this breakthrough process for producing aluminum. They called him the aluminum boy wonder in the press. And probably no one ever made more money more quickly on the periodic table than Charles Hall did. Because when he founded his company, it's called Aluminum Company of America, known as Alcoa. When he founded Alcoa, he was shipping out about 50 pounds or so of aluminum each day, and that was plenty to meet demand. 20 years later, he was shipping out almost 90,000 pounds of aluminum every single day, and he could barely keep up with all the orders. He died a very, very wealthy man simply because of his knowledge of this one then obscure element on the periodic table. And I like this story because it makes me think about how the fortunes of the elements really do rise and fall over time. There are some elements nowadays that we take very seriously, very precious to us, that in the future maybe they'll giggle at us that we were so enamored of these elements. Conversely, there might be elements that no one pays attention to nowadays that in the future might be worth a lot. They might be world-changing, civilization-changing elements that today we just overlook. We don't really pay attention to. The fortunes really do change of these elements over time. That's one thing I tried to do in the book, was to show you how those fortunes change and how the elements play these unusual roles in our everyday lives sometimes. So again, that was my first book, The Disappearing Spoon. And then a couple years after that, I wrote a second book called The Violinist Thumb, which is about genetics. And the reason I really was excited about this book, there was one thing that kind of always fascinated me about the world of biology generally, but specifically about genetics. And that genetics was really kind of the unifying theme, the universal thing that brings all of life together. Because if you think about it, any known form of life that we can think of, that we've ever discovered, has genes, and it has DNA in it. Any known form of life. Whether we're talking about tulips, guinea pigs, bacteria, toads, toadstools, slime molds, dung beetles, members of Congress, whatever. Genes and DNA work the same way in all of these bizarre creatures. And I just thought that was really fascinating. There's one thing, at least, that all known forms of life share. But pretty early on in researching and writing this book, I realized that there was one thing that's noticeably different when you're talking about the genes and DNA of most animals and the genes and DNA of human beings. A striking difference between them, I would say. And the thing that's very strikingly different is the names of the genes and the names of the stretches of DNA. Because the names of them are very, very different. If you've ever looked at a medical paper or maybe read a newspaper, magazine story talking about genetics, they might have mentioned a human gene in there. Often abbreviated, but if they've ever spelled it out, these human gene names are really awful names. They're very long, very jargony. There's random numbers and Greek letters appearing in the middle. Very, very intimidating, kind of hard to parse words. So not fun to read about these names or to read these names. But it turns out that with the genes of animals, scientists have a little bit more leeway. They can be a little more creative, have a little bit more fun. They can actually, they can express themselves. They can have a little bit more fun. Specifically, that's a double helix right there, just as a quick refresher. Specifically, though, I'm thinking about the gene names of these guys right here, the fruit fly. Now, they probably don't look it. They may not look particularly witty, but the fruit flies actually inspired more creative and unusual gene names than probably every other animal out there combined. There are different fruit fly genes named Groucho. There's one called Smurf, Lost in Space, Fear of Intimacy. There's one called Tribble, after those multiplying fuzzballs on this very famous episode of Star Trek. There's the faint sausage gene. I have no idea what the faint sausage gene does, but it's kind of a lovely poetic name. There's the Tin Man gene. And if the Tin Man gene gets mutated, fruit flies cannot develop a heart. So that kind of makes sense. Oh, thank you. There's a gene that leaves fruit flies exceptionally tipsy after a tiny, tiny sip of alcohol. It's called the cheap date gene, so it kind of makes sense. Probably my favorite gene name, though, was not originally discovered in a fruit fly. It was actually discovered in a mouse. And that gene name is the POK erythroid myeloid ontogenic gene. Now, at a first glance, that is a perfect example of a terrible gene name, where you're just looking at these words, and unless you're kind of an expert, they might be even hard to parse what's going on here. But if you look a little bit closer, the first three letters are POK, then there's an E, then there's an M at the beginning of the next word. It kind of spells out Pokemon. And in fact, the scientists who discovered this gene, they named it the Pokemon gene, published a paper about it, and everyone kind of had a good laugh that there was this silly name for this gene, the Pokemon gene. Except you can see maybe right after the word Pokemon there's a little R with a circle around it. And that means copyright restricted. And the lawyers at Pokemon Inc., it turns out, were not very amused about this because the Pokemon gene actually contributes to the spread of cancer in mice. And they kind of understandably didn't want their cute little pocket monsters confused with tumors. So they actually threatened to sue the heck out of these scientists. They were really going to take them to the cleaners over this until the scientists, and they finally backed down and they gave it, I don't really remember just some other terrible gene name. But for one shining moment, there was actually a Pokemon gene. Now, one thing people often ask with my books is they want to know why I named my books what I did. So this book's called The Violinist Thumb. It's not an obvious connection to genetics. So why would you call it The Violinist Thumb? So I thought I would go over that story briefly of why it's called The Violinist Thumb. Now, obviously, there is a violinist involved in this. This man right here, named Niccolo Paganini, usually considered the greatest violinist who ever lived. So he was active in Europe in the very early 1800s, and pretty much every king, every emperor, every queen wanted Paganini to come play for them because he was the absolute greatest violinist of his time, probably of all time. Have you ever heard those stories about people who have sold their soul to Satan in order to get their musical talent? It's often with blues musicians nowadays, but a lot of those stories actually started with Paganini because they figured there's no way someone could be this good at playing the violin unless he had made some sort of compact with the devil. Well, it turns out there were some nonfiction reasons that Paganini was such a good violinist too. The most important of them, perhaps, was that he had these amazingly, even sort of freakishly flexible hands. So one thing he could do with his hands, he could take his pinky like this, just holding it up like this, and he could bend his pinky into a right angle with the rest of his hand just by stretching it out like that. And it actually gets worse because he could also, imagine putting your hand down flat on a table like this, palm down, and then raising your thumb and your pinky. So Paganini could do this. And he could actually touch his thumb and his pinky behind his hand just by raising them like that. So he could do things with his hands you should not be able to do with your hands. But that actually gave him a big advantage when he was playing the violin. He could stretch his hands incredibly wide. He could do fingerings that no one else could, which meant he could play music in ways that no one else could, and sometimes even songs that no one else could actually play. And from a modern perspective, it's almost certain that he had a genetic disorder of some sort. Because it wasn't just his hands that were very flexible. All his joints were. He could bend his elbows the wrong way, his knees bent backwards. He was a bit of a circus rubber man in that he could just twist himself into all sorts of shapes. And the reason I chose that as the title story for this book, there are actually a couple reasons for this. First of all, we usually think about something like music being on one end of a spectrum, the fine art, and something like genetics, a science, being on another end of a spectrum. And it seems like there won't be any connections between them. But it turns out in this case, if you know a little bit about the music and know a little bit about the genetics, they actually inform each other. And I think it's a better story if you know both the genetics side and the music side. When you see those connections between them, I think it really improves the story. And that's one thing I do try to do in my books, is to show that science does connect with so many other areas of life if you just dig a little bit deeper. Talk about science in war, science in poison, science in politics, all sorts of different things if you just know where to look. There was another reason I chose it as the title story too, and that was I think there's a good science lesson buried in here as well. Because Paganini did have these amazing hands. They were definitely a big boost for him. But in addition to that, he was also a very hard worker, and he loved playing and practicing music, and he grew up at a time and a place where violinists were rewarded. They were basically the rock stars of their day. So it was kind of a perfect storm of all of these things coming together to make him who he was. And that's a good lesson nowadays when you're talking about things like human genetics. Genetics are very important. They have a big influence on who we are. But they're not everything. They're certainly not everything. Scientists nowadays are talking about genes and the environment, gene-environment interactions. That's really where the field is going. You can't talk about isolated genes, something like his flexible hands, and know as much about him. You need to talk about when he grew up, where he grew up, his temperament, things like his psychology. You really need all of those pieces to understand someone. So the genetics is an important part of it, but there's more to this story. There's more to even the genetics than just what's inside his cells. It's the genetics and the environment. I think the story of Paganini kind of brings all of those things together in a nice little package, which is why I thought it was a good way to go for the title of this book, kind of a memorable, fun story that brings all of those things together. So again, that was my second book, The Violinist's Thumb. Then a couple of years after that, I published a third book called The Dueling Neurosurgeons. This book obviously is about neuroscience, kind of psychology, neuroscience, things like that. And another question people often want to know is they want to know, why'd you pick this topic for your book? I mean, there are thousands and thousands of scientific topics even you could pick to write a book about. Why did you pick this topic to write about and not all of the other ones? And I can say with this book, what really inspired me was doubt or skepticism, mistrust, whatever you want to call it. Because a few years ago, I was reading a story about someone who got injured in one part of his brain, and his behavior shifted in this very unusual way after this injury. And I said to myself, that sounds like bull sugar. I said, I don't think I quite buy that the author got the details right. I think they made some sort of mistake. I just don't believe this story. But then, kind of forgot about it until a couple weeks later, was reading a different book, and something similar happened. It was a woman this time, got injured in one part of her brain, and her behavior shifted in this very unusual way. And I thought, I just don't believe that. I think the authors got this wrong. So I kind of set out to show that these authors were, in fact, wrong. And eventually, of course, ended up feeling kind of dumb because they were right and I was wrong. I was the one who was incorrect in this case. But I couldn't stop thinking about these stories kind of day after day. They kind of followed me around. So what kind of stories were these? Well, I'm sure we've all heard stories about people who've gotten injured in one part of their brain, maybe lost the ability to speak, or maybe lost the ability to form memories, something like that. But what really captured me about these stories was how specific people's deficits were. So for instance, I think we can all generally recognize what types of animals are up here. Even if we don't know genus and species, we can tell, it's monkeys, birds, whatever. But it turns out that there is one spot in the brain, in the temporal lobe, so on the temples, on the side of your brain, there's one spot in the temporal lobe of the brain that if it gets nicked, all knowledge of animals will disappear out of people's minds. So these people can tell plants apart, no problem. They can tell individual human faces apart. They can tell different human-made objects apart. But dogs, raccoons, elephants, fish, whatever, look exactly the same to them. They cannot tell these creatures apart. Or something sort of similar can happen if you get another spot slightly farther away damaged. Knowledge of plants will disappear. And these people can tell animals apart, but they can't tell plants apart. And I looked into it more and started thinking about it, and I realized, okay, this actually kind of ties into our evolutionary history. So if you think about our ancestors way back when, wandering around the savannah or whatever, some people were probably better at classifying and recognizing different types of plants and animals. They could say, okay, these animals are good companions. We should be friends with them. These ones are good to eat. We should hunt them. These ones are dangerous. Stay away from them. Same with plants. These are good medicine. These are poisonous. These are food. And the people who were able to classify and recognize different types of plants and animals ended up having an advantage, and over the long term, this ability sort of got hardwired into our brains. And we all have this ability to a greater or lesser degree today. And that gave us an advantage as a species. But the disadvantage of having this hardwired circuit in the brain is that if that part gets injured, then poof, that knowledge can disappear. And that seems to be what happened with these people. So it relates back to our evolutionary history. And the second story about the other deficit I thought was even more unusual. So again, we probably all heard stories about people who get injured and then they lose the ability to speak. And I've highlighted here a very famous area of the brain called Brocas area. It's very intimately involved with producing language. And if you have a stroke or something, or that part of the brain gets damaged, you just can't get words out. You just really, really struggle to speak. And it's frustrating to watch. It's very frustrating for the people. It's really a sad situation when the Brocas area gets damaged. But in some people, something slightly different happens. Because the Brocas area itself is fine, but they suffer damage to another part of the brain. So if you think about it, the brain is producing language up here, but the speaking happens down here in your mouth. So somehow the information has to get from your brain to your mouth. And that information gets sent along neurons and nerves. We can think about them basically as biological wires sending information from the brain down to the mouth. And in some people, the Brocas area producing language is fine, but the wires get broken. The wires get damaged. So it's like someone came and snipped a wire. The information can't get across. So in these people, again, they can't produce language because of that broken connection. One thing you learn about the brain, though, pretty quickly as you're studying it, is that there are a lot of alternative pathways, other ways for information to get sent around, detours, back alleys inside the brain. And it turns out there is a detour that runs from the Brocas area of the brain into the emotional centers of the brain. And then the emotional centers of the brain can still connect to the teeth, the tongue, and the lips. So with these people, because the direct connection to the language center is broken, they can't speak. They just can't get words out. But if you provoke them, if you rile them up, you get them angry, you get their emotions involved, it turns out that they can swear at you, no problem at all. They'll say you beepity beep beep, and then they'll sort of jump back, because in a lot of cases, they didn't realize they could produce any words, much less words like this. It bubbles up out of them, kind of from the subconscious, and they didn't know they could do that. There's a similar thing that can happen in that there are connections between the language centers of the brain and then the musical centers of the brain. And the musical centers can still get in touch with the teeth, the tongue, and the lips. So these people, they can't have a regular conversation, but they can still sing song lyrics, no problem at all. In fact, there was a congresswoman from Arizona a few years ago, Gabrielle Giffords, was giving a speech when someone shot her. She got shot in the head, had to go to rehab for this. And she was one of those people who couldn't speak, but she could sing. And while she was in rehab, she ended up singing, she could sing songs like Girls Just Want to Have Fun was one of the songs she could sing. I'm not sure why Cyndi Lauper, like kind of all the songs, stuck in her head, but by practicing singing, she was eventually able to rehabilitate herself and regain some ability to speak. So knowing this little bit about the alternative pathways in the brain it helped people rehabilitate themselves. And I was kind of thinking about these stories as I was looking into them, and I thought, boy, that's really interesting. Just based on these two little injuries, I already learned a lot about how the brain works. And I thought, boy, I bet you could write like a whole book just about different injuries and what it teaches you about how the brain works. And then sort of the cartoon light bulb went off over my head, and I thought, boy, I should write a book like that. So that is what this book is about. Because if you think about it, until maybe 25, 30 years ago, neuroscientists had no way to look inside the brain except for waiting for people to get injured in a certain part of the brain and then just seeing how their behavior changed after this. So it's a bunch of case studies, basically, of people who have unusual brains, how their behavior is different, and what that teaches us about the brain. And I thought I would wrap up the talk with a brief story about one brain, a very unusual brain, that wasn't injured, but that was just shaped in a little different way. And this story, so far I've been talking about things like recognizing animals, things like that, kind of basic low-level things. But this next story gets into some really highfalutin, really high-level things about our brains. So this story gets started a few hours outside of Vancouver, about the year 2005 or so. So there's a woman there who found out that she was pregnant, found out she was having twins, actually. And so she was very excited about that. Except at one of the later sonograms, the doctor said, I'm sorry, I have some unfortunate news. Your twins are conjoined. What used to be called Siamese twins. So basically they had fused together inside the womb. So it was kind of tough for the woman, but she decided she was going to have the babies, brought them to term. And as you can see in the picture here, the babies actually had a Siamese brain. They share a brain inside their head. And I should emphasize that the girls, Krista's one and Tatiana's the other. They are still alive today. They're fairly healthy, fairly happy. They go to school, they have friends. They kind of have a fairly normal life. But because they do have this Siamese brain, they show some very unusual behaviors. And in fact, behaviors that scientists have never seen before. So specifically, the part of their brain that's connected is a part called the thalamus. The thalamus is in the center of our brains. We all have one. In the center of our brains. And it's basically a relay center for sensory information. So information comes in through our eyes, our ears, our mouth. One of the first places it goes is to the thalamus. And the thalamus sends it off for processing in other parts of the brain. So it gets sensory information, relays it to other parts of the brain. And the two girls, Krista and Tatiana, share a thalamus, which means in a lot of cases they share sensory information. Okay, well, what does that mean? They share sensory information. How does that actually work? Well, it turns out that if one of the girls is, say, taking a sip on a cup of juice, her sister can actually taste the juice in her mouth. You give one of them a shot at the doctor's office, the other one grabs her arm in pain. You tickle one of them, the other one starts to laugh. They fall asleep together. They maybe even dream together. And again, scientists have never seen anything like this, in part because it's very rare that you would have a Siamese baby, but then also that they would survive. And so in a lot of ways, this is brand new territory. And it raises some kind of interesting and maybe a little bit uncomfortable questions. One of the obvious ones is, they're sharing sensory information, sharing consciousness to some degree. So are they two individual people, or are they kind of one person spread out over two bodies? And maybe there's not a nice, clean answer to it. Maybe it's a little bit ambiguous and will remain that way. But I think most of the evidence actually points to them being two individual people, at least the anecdotes that I've seen so far do. One thing, for instance, the girls often walk up to someone and they'll say something like, I am just me. Now that's kind of an odd thing to say. Like none of us would walk up to someone and say that. But the girls apparently feel like they are individual people. They feel independent. They kind of want to assert themselves as independent people. So I think that should count for something, the fact that they feel like they are independent. And I think the other anecdote is maybe even more revealing in that it turns out that one of the sisters really likes ketchup. I mean, she loves ketchup on hot dogs, on fries, on everything. Unfortunately, her sister really hates ketchup and is always kind of scraping her tongue because she can taste it when her sister's eating it. And it's kind of an amusing anecdote, but there is a good lesson there in that the two girls are getting the same basic sensory input, but they're reacting to it in very different ways. They're reacting to it as individuals would. So even on some sort of physiological, psychological level, they are acting as individual people. And there are a lot of cases like this in the book where I talk about things like consciousness, free will, memory, language production, these big high-level things that have been affected either by injuries or by unusual brains. And these are a lot of cases are things that scientists have been debating for hundreds of years, but you get this unusual brain and suddenly get a little bit of traction on it. You can understand a little bit of where it's going just based on these different cases. So these cases aren't all in the remote past. There are people living nowadays studying their brains where we're learning these big important things about not only how our brains work on a very fundamental level, but big important things about free will, consciousness, the big important questions about life based on some of these case studies. So I'm actually going to wrap up here. I'm going to skip over, not going to talk much about my fourth book, but just wrap up here with a slight confession in that, so far I've been telling you these true stories about different scientific things. But I was tricking you a little bit too, I have to admit, in that I was slipping a little bit of science in there, hopefully under the radar, and hopefully you learned something, maybe even against your will, about some different areas of science just based on these stories. And in fact, I think stories really are a very good way to teach science in some cases, because the human brain is very, very good about remembering information when it's presented in a story form. If there are good guys and bad guys and conflict and drama, all those juicy things that make a good story, if you can find that within the science, we really are good about remembering that, as opposed to the facts, data, dates, things like that. We're not so good with that. So if we can present it in a story form, it really does help sometimes get the information across. And I hope you can walk away from the talk this afternoon with an appreciation not only for the stories, but for the science behind them as well. So again, thank you everyone for joining me this afternoon. I appreciate it.
I think we have some time for questions. Anyone?
While doing research for your books, was there a favorite, not necessarily a favorite story, but like, was there a book that you had the most fun doing research for?
So she asked if you didn't hear, was there a book I had the most fun doing research for? I think so. So my books, I was telling the class this morning, my books have changed a little bit in that my first book about the periodic table, a lot of information to get in there, so it was kind of quick cuts, moved, it jumped around a lot. And then the next book, each one has sort of progressively, the chapters have gotten a little longer, the stories have gotten a little more in depth. And actually I have a new book coming out this summer where it's, instead of having like some short stories, it's more like one novel, in that it's one longer overarching story. So the new book, it was a lot of fun to kind of go into archives, dig into things like that, and do some of that work and really focus on one longer story. So I did have a lot of fun doing that research. Yep.
Was Tourette's an example of the inability to speak unless provoked, until provoked, and then coming out with the symbols? I mean, a bad word or something?
Yeah. Excuse me. So we asked about Tourette's and whether that was an example of the swearing that I mentioned. Tourette's is actually different, I think, in that Tourette's is more of an inability to sort of clamp down on impulses that you have in some cases. Words come out. So these people aren't necessarily agitated, the words kind of bubble up. So there's a similar dynamic in that it might be against their will or something, but and Tourette's isn't brain damage either. These people have had brain damage where something happened. So it's different, but there's kind of an overlap there in some ways. Yep.
This is a great talk,
Thank you.
So you talked a lot about your time in college, and then you talked about your first book. Could you just talk about your sort of trajectory between college to producing like a whole book, which seems like this big project to kind of complete?
Yeah. So during college, I worked at the campus newspaper, University of Minnesota, which was a great experience. In that I was about the only person on staff who had any sort of science experience, which meant I got to write a lot of stories that I probably wasn't qualified for, didn't have enough experience for, just because they're like, the editors would be like, science, and just hand it right off to me. They didn't want anything to do with it. And it was also a good experience as a young writer to be producing things on a regular basis. You didn't have time to be precious with it or something. You had to get it done. You had to get it out there. It got edited very quickly, or very immediate editing, things like that. That's a good thing, I think, for young writers to have that good feedback. So I worked at the campus newspaper, spent a couple years back in South Dakota writing on my own, just filling notebooks and things, writing stories, writing other things, just getting practice, putting the words in the right order, sentences, just working on practicing writing the way you would an instrument or a sport or something like that. Eventually moved out to Washington, D.C., did an internship at a newspaper out there, then got a job at that newspaper, and then bounced around to a couple of different magazines. And that was at the point I realized that magazines weren't the best fit for me. I like them to some degree. I still do work for them, but books gave me a little bit more about what I wanted. So it was a combination of working for publications and getting a lot of feedback, but also putting in a fair amount of time on my own, just doing my own writing the way I wanted to. So, yep.
So the title of the Dueling Neurosurgeons book, I know I think you kind of talk about Perret and Basilius.
Uh-huh.
Were they the inspiration for the title, or it kind of moves into like damaged brains and stuff like that towards the end? Was that like the theme of it was from the two surgeons, Basilius and Perret, and that like kind of just led to the rest of the story, or was there more behind that?
Yeah, so she asked about the title for the Dueling Neurosurgeons and where that came from. And she mentioned two of the, kind of the two surgeons of the title, Ambrose Paré and Andreas Vesalius. And yeah, they were the inspiration for it. That's where I got that. So just briefly, the story was about a king of France, kind of this big macho king, and he got into this horrific jousting accident one day where a lance hit him in the head. He suffered what was then a very controversial diagnosis, a concussion. And so they brought in the two best neurosurgeons in the kingdom to try to save him. And usually you don't think about, the story took place in the 1550s. So usually don't think about neurosurgery going on way back then, but they did have neurosurgeons, and that's kind of the inspiration for the title. So yep.
Last one.
All right.
So I have a question about the way you ended the relationship between science and storytelling.
Uh-huh.
And I read this really interesting article in the New York Times Magazine some months ago about, this isn't hard science, or maybe it is hard science to some people, but the field of psychology and this replication crisis that they're having in psychology. And
Yep.
the story focused on this woman whose name I'm forgetting, but she discovered the power poses.
Amy Cutter,
Amy, yeah.
Cuddy or something, yeah.
Amy, yeah, that's it. Amy Cuddy. She was at Harvard, and so she came up with this scientific finding, which is like power posing transforms your self-confidence and your mental state and such and so, and and psychologists who are able to tell a great story about their finding, kind of like where
Oh, yeah, yeah.
she got hot in the field, and she got very hot. She got a job at Harvard. She gave the most famous TED Talk. She's a corporate consultant. And then it turns out you can't replicate her findings at all. It was a fluke, or she kind of messed with the data until she got a P-score that she liked. And it seems to be a problem all over the field of psychology. And the new movement is like, stop trying to tell interesting stories with your science, because it will distort your science, it will distort your goals. There's this guy named Shankar Vedantam who's always like telling interesting stories about social science on the radio. I just want to strangle him every time I hear his voice. Because he's taking these like kind of interesting findings and making them seem more profound. So anyway, I was curious about, you were writing about the hard sciences. I'm curious about how this works out in the hard sciences in a storyteller like yourself. Like in a way I can imagine, good, these scientists can do like the boring lab stuff, and they probably talk about it in a boring way, and they can leave the stories telling the same, And, or do you feel like the hard sciences are starting to get intoxicated by the idea of, let's tell great, interesting stories about what we're doing?
No, I don't think they're getting intoxicated. I think I would draw a bit of a distinction between something like telling what I'm trying to do is often talk about the scientists and the research they're doing. They're often taking their findings and telling a story about what the data says, something like that. So I would draw a distinction between that. And I do think that part of the reason there's been this replication drive, there were fundamental scientific flaws with a lot of the papers that they're having trouble replicating, small sample sizes especially, sort of a bias against publishing positive results versus burying negative results, people not posting what they're going to do ahead of time, fudging with data, things like that. So I think it's basically impossible to eradicate the idea of storytelling in science because it's so ingrained in the human brain. But that is a good, interesting point. I hadn't heard it quite put that way, that you can be seduced by stories as well. And maybe it is more of a danger in a field like psychology, where you're already dealing with the mind and things like that, as opposed to something like a hard science, where you're not so much dealing with human beings and human emotions and things like that. So, yep.
You said, when you were talking about the Siamese twins and the other cases, you said by studying them, you could learn a lot about what consciousness was and free will. What did you learn?
Well, not so much them necessarily as stories like them, other different stories like that. Consciousness is a difficult one in that there are so many different parts of the brain involved. We don't quite know exactly what is going on. We know there's not like a consciousness spot in the brain that'll light up or something. We know it's basically spread all over the brain, and damage to different parts can affect people's consciousnesses in different ways. The neuroscience, or the free will part, it sounds like kind of a bummer, but neuroscientists mostly don't believe in free will. They've just seen experiments and things where they've just seen evidence where they look at it and they say it's very hard to square this with the traditional idea of free will. But it's very interesting because we all believe in free will. You can't not believe in free will. So there's that dilemma where the science says one thing, we feel another thing, and it's possible the science is wrong. It's possible our feeling is an illusion. We don't quite know exactly what's going on. There's really a tension there between those two things. So that's an example of something that's kind of unresolved at this point.
One other question. That disappearing spoon, is that an aluminum spoon?
Well, so it is related to aluminum. So I can just tell you the story briefly. So there's an element that sits right below aluminum on the periodic table. It's called gallium. And gallium and aluminum, because they sit right next to each other, are very similar. If you had a chunk of one and a chunk of the other, you pretty much would not be able to tell them apart. Except that gallium has one unusual property, and that it melts at about 85, 86 degrees Fahrenheit. So on a warm day, you're holding some gallium in your hand. It will melt. It will start to run down your fingers, turn into a liquid. So the title, The Disappearing Spoon, comes in because it's sort of a classic nerdy science prank to make a spoon out of gallium metal, and then you serve it to somebody with hot coffee or tea or something like that. And you can imagine what happens. They start stirring the tea with it. It melts. It disappears on them. So that's where the title comes from. So kind of Illuminish. So if there are no more questions, I'm going to briefly plug my new book, if you could humor me for 1 second. But I have a book coming out this July that I'm very, very excited about. So it basically involves an offshoot of the Manhattan Project. What happened essentially was that there were a bunch of scientists in Germany who got run out of Germany by Adolf Hitler. They came over, worked on our atomic bomb project, the Manhattan Project. But they were pretty scared, pretty worried that Germany was way ahead of us in atomic bomb research because atomic fission had been discovered in Germany. They had a bunch of Nobel Prize winning scientists there. They had already started their Manhattan Project, their version called the Uranium Club. They'd started that right at the beginning of the war. And they had the best industry in the world, which means they could put it all toward possibly making an atomic bomb. They were convinced that Hitler was going to get an atomic bomb and going to destroy the rest of the world with it. So these people convinced the head of the Manhattan Project to put together this team of undercover kind of scientific commandos and send them into Europe to spy on and sabotage, and in some cases try to assassinate members of the Nazi atomic bomb project. So the book is about this group of scientists, some of the adventures they had running around Europe trying to stop what they thought was going to be the Nazi atomic bomb there. So it was a very fun book to write, a lot of great characters in there, different people like that. So I hope you can check it out. But in the meantime, thank you all for coming. I should mention the title for it too. It's called The Bastard Brigade. So, The Bastard Brigade.
I like it. We have another related event tonight at 5 o'clock. It'll be 106 downstairs. So that's a panel discussion including some of your favorite UNE faculty, as well as Sam, picking up on some of the questions about storytelling and so on. We have copies of Sam's books for sale. If you'd like to grab one and get an autograph. And hopefully I'll see you all at 5. Thanks.